Let's look at one last example of the basic randomized comparative design with two factors. The mango is considered the king of fruits in many parts of the world. Mangoes are generally harvested at the mature green stage and ripen during the marketing process of transport, storage, and so on. During this process, about 30% of the fruit is wasted. Because of this, the impact of harvest stage and storing conditions on the post-harvest quality are of interest. And I think specifically that interest is probably monetary. So if 30% of the fruit isn't making it to market in a sellable condition, that's going to drive up cost and prices, as well as just the waste factor, right? So anything we can do to minimize the amount of food wasted is probably a pretty good thing. In this experiment, the fruit was harvested at 80, 95, or 110 days after the fruit set on the tree. So that term fruit set on the tree is when the flowers on the fruit tree transition into what looks like little hard balls. And we used to throw those around on the playground when I was a kid, which is a terrible thing to do. They're kind of painful when they hit you. But when it makes that transition from the flower to those little hard balls, that's what we call the fruit setting on the tree. And so then the fruit was harvested either 80, 95, or 110 days after that happened. And then it was stored at temperatures of either 20, 30, or 40 degrees. For each combination or treatment of harvest time and storage temperature, a random sample of 10 mangoes was selected from the available mangoes that met that fruit setting criteria. So for example, we might have an entire bin of mangoes that were picked at 80 days after the fruit set on, and we'll take random samples out of that bin. Then the time to ripening was measured in days. So what you're going to do or need to do is you're going to need to figure out how many treatments you have so that you can figure out how many mangoes you need to start with in your sample. So you notice there wasn't a sample size given. All they said was that they want 10 mangoes in each of the treatment groups. So you're going to need to figure out the factors and the levels and use that to determine the number of treatments, and then multiply that by 10, and that'll tell you your starting sample size. And then go ahead and work on diagramming that experiment. So what I'd love for you to do is go ahead and pause the video and give this a try. All right, so let's figure out what this sample size needs to be. So the fruit was harvested at 80, 95, or 110 days. So that gives me 3 levels. And then it was stored at a temp of 20, 30, or 40 degrees. So that's also going to be 3 levels. So if I take 3 times 3, I know that I'm going to have 9 treatments total. And then if I take those 9 treatments times 10 mangoes per treatment, I'm going to start with a sample of 90 mangoes. All right, so here we go. Here's our 90 mangoes. This was sort of a random sample. It was a random sample from all the fruit that was picked at that time, but I don't know that I would call it necessarily a true random sample. So I usually make a little note there. And then here I have listed my factors and my levels. So we know that we need 9 groups. So I'll take my 90 mangoes and make 9 groups that each have 10 mangoes in them. And then for the treatments, so you could certainly draw that tree diagram off to the side and kind of work out what those treatments are. With a little bit of practice, what you'll see is I could take this first level, the 80 days for the first factor, and use it with each of the temperatures. So I'd have 80 days in 20, 80 days in 30 degrees, 80 days in 40 degrees. Run out of those. So then I'll start with the 95. I'll go 95 days and 20 degrees, 95 and 30, 95 and 40, and then same thing with the 110. So you don't have to make a separate diagram if you don't want to. There's a couple of tricks to get around that, and this is one of them. So here are my 9 treatments, and then my response variable here is the time to ripening, and that's going to be a quantitative variable, and it's measured in days. All right, so on your notes, you actually have one additional question. It says, for simplicity, the experimenter thought about selecting 9 mango trees and randomly assigning 1 tree to each of the 9 treatments. All the mangoes on a tree would then receive the same treatment. Do you think this would be a good way to assign the mangoes to treatments? So no, this is probably not a good idea. And the reason for that is that if you're using a tree that's maybe at the end of the orchard, it's going to have more sunlight than a tree that's in the middle of the orchard, right? It's going to have at least one side, maybe even two sides of the tree that are getting full sunlight versus one in the center is only maybe getting that sunlight at the top. Right? So that sunlight could be a factor, the watering could be a factor, the dirt could also be a factor. So when I was in fourth grade, we built a house, as in my parents brought us out and we helped them nail all the nails and cut the wood and do whatever they needed done. And we worked on this house every day after school and weekends and summer. And once it was built, my dad planted a lemon tree, and lemons are like one of my dad's favorite things. So he babied this tree. He would go out there and cover it with blankets if it was going to frost. And he just could not get this thing to grow. No matter how much fertilizer he used, no matter how he changed the watering. So he finally got frustrated and he pulled it up out of the ground and he was just like, I guess I'm not going to have lemons. And he put it in the compost pile, intending to deal with it later. And he got busy as people do. And the next thing we know, we go out to the compost pile and this lemon tree has rooted itself in the middle of the compost pile and it's sitting completely upright now and it's got lemons blooming on it. And my dad was just so shocked because he spent all this time caring for it. It refused to grow. He basically throws it away and the thing is happy as a camper. So we go back over and look at the dirt and we dig down and what we find is there's a lot of oil in the dirt. So this used to be an old farmland and our guess is that maybe a tractor or something broke down and it just leaked oil, it leached into the ground and we had no idea until we tried to plant something there. Right, so there are all those factors that you might not even be aware of that could be influencing or biasing these results. So no, it probably would not be a good idea to just assign a tree to each treatment group.